If you hang out at all on the OpenDaylight IRC channel or do in the future, you won't find me under my name. You'll find me under the handle regexboy. So I figured let's put it up there now so everybody knows how to find me if any questions come up. A little bit different than some of the other sessions. I'm not going to stand up there. I tend to wander around a bit, and there's no steps here, and I'm afraid I'd take a header off and we'd all get to have a show we don't want. Second thing that's slightly different, I'm not handing out VM sticks like was done at the Neutron tutorial this morning. Sorry. However, I will promise you that everything that's in the demo, there are wiki pages that we will point at the end that are part of the OpenDOVE wiki site that you can follow along and fill in and recreate what we do here on your own deployment. All right, with that being said, let's get the mouse in the right window. And, aha, there we go. All right. So, OpenDOVE, well, DOVE stands for Distributed Overlay Virtual Ethernet, or something like that. It has a little bit different view of the world than some of the overlays that you've seen here and heard about. We model a virtual network as a collection of what we call domains, virtual networks, subnets, most importantly, policies. OpenDOVE is all about a policy view of the world. And then we have gateways, which we'll talk about what they're for as we go along. Domains for us, if you're familiar with the Neutron model or the OpenStack model, domains is sort of our word for tenant. Virtual networks are fairly close to networks, not quite. Subnets, yada, yada, yada. So basically, the big thing to know, and this picture is showing, is that in DOVE, and in OpenDOVE, I should say, a domain is a hard administrative boundary. I can do lots of policies between virtual networks within a domain, but if I want to cross a domain, I'm going outside the cloud to a gateway, through a gateway, and coming back in. So we have a slightly different view, as I said, of the world as some of the other people that you've heard about. OpenDOVE consists of 5 major components. The ODMC, the DOVE Management Controller, it's currently packaged in the Virtualization Edition. It provides both basically the access point and the control point for the management plane. Now, you've probably heard about data planes and you've heard about control planes. One of the things that OpenDOVE has is a management plane in addition. We split the management plane from the control plane. So if the management controller dies, the management plane goes away and you can't do any more management, but the control plane's still there, the data plane's still there, packets still flow. It's one of the trade-offs that we decided to make. Second part, the OpenDOVE connectivity server. We'll explain what that does. It's packaged as an RPM. Basically, it's the control point for the control plane that I just mentioned. The gateway, packaging TBD, this is where I get to make my mea culpa. We ran into a non-technical snafu at the last minute, so the Hydrogen release doesn't have a complete version of the gateway. If you download the source code, you will get the user agent. The gateway also needs a kernel module. It happens to be GPL. We ran into some snafus with where we could host it. We're getting those fixed, and very quickly we will have the full functionality available. This thing provides gateway functionality, hence the name. NCAP, DCAP, when we need it, network address translation between the overlay and the outside world. And then last but not least, we use OVS 2.00 in our hosts. We have an OVS agent that, oh, I hacked that. That's also packaged as an RPM and handles the interface between the OVS and the OpenDOVE control plane. Okay, that's text. That's boring as heck. Let's get a picture up here. So here's what I just said pictorially. All right, so starting at the top, we have the OpenDaylight controller, and we have the ODMC in it, and the Neutron API, which you guys heard about earlier. In addition, there are some zero-day configuration things that we do via REST. One more administrative note. We've got 2 hours here. Feel free to ask questions. Otherwise, we're going to be done real fast. Now, if you want to get done real fast and go to one of the other sessions, by all means, don't ask questions, and it will be all done. OK, so the OpenDaylight controller, as I said, has the ODMC. It talks REST to the DCS and the OGGW, and also it talks to the OVS agent. We ran out of space on this line, but there's a REST piece to that triad as well. The ODCS is set up as a system to basically a distributed database across multiple instances. So you can have, I believe it's up to 20 of them before things get a little hokey. They talk their own cluster protocol for sharing the distributed database amongst themselves. And they talk ODS, what we call the DCS cluster protocol, or ODCS-CP, down to, or CSP, I should say, client server protocol, down to the gateway and the agent. Well, we'll answer the first question, why not OVSDB or OpenFlow? Answer, the work on this particular protocol was finished before OVSDB came along and got hot, and one of our open topics is, do we stay with this or do we get rid of it? It is encased in the source code for the implementations that you can download from the repository. It is also going to be documented as a private space internet draft. The author of said draft ran away, so I couldn't point him out and shame him into getting it published. Life goes on. So the OVS agent, one of the other interesting things is it sits right here. We ran out of space for labeling it, and it translates that client-server protocol into OpenFlow. And the reason it's not up in the controller is simply one of getting things done by the Hydrogen release. Obviously, we have lots of open issues to address. One of them is, how much of this do we just pull up into the controller and start using OpenFlow and pushing things down? Yes, question.
So I have a question on basic OpenDaylight. How do you improve discovery of the nodes that they support this or some other architecture that have this?
So the question was, in the OpenDaylight controller, how do you discover nodes, switches, nodes, and their capabilities? So in the case of regular OpenDaylight, to the best of my knowledge, OpenFlow, the switches use OpenFlow to communicate up and talk about who they are. In our case, the OVS agent makes a REST request and heartbeat up to the controller and says, I'm here, and our ODMC piece of the controller is listening to that URI, and we keep track of what switches we know about. We don't talk to regular OpenFlow switches that are out there. They're a separate dark space as far as we're concerned.
How is the controller discovered by the switches?
So the second question is, how is the controller discovered by the switches? So today, and this is an open topic, and if anybody has a better idea for how to do it, please contribute code. Today, that is semi-preceded. We actually seed the information about where the controller is. Once the switch knows where the controller is, it can figure out where all the cluster servers are to handle the rest of it. So we seed it with a little bit of information. And again, it's an open topic. How can we get that to zero configuration? Because we don't like doing zero-day things, but we have to. Another question? OK. Yeah. So basically, you can think of, as far as planes are concerned, the top level is the management plane. The middle tier is the control plane, and the bottom layer is the data plane. Although that's not quite exact. That's not quite accurate, but it's close enough for government work. All right, so let's talk a little bit about each of these components. So, or maybe let's not talk about each of these components. There we go. OK. So a little bit about the component structure. If you go get the code from OpenDOVE.git, what you will find is the ODMC consists of 5 bundles. Maybe it could have been smaller. We sort of followed the basic OpenDaylight structure where you have the basic data model in one bundle. You have an implementation of all your contracts in a second bundle. Because we handle REST requests and we don't talk to the SAL at all, we have a separate REST bundle which has our common contracts, and then northbound and southbound listeners are sitting in those 2 bundles. Now, one of the open items is that for meeting the hydrogen release, the only piece of OpenDOVE that is in Java is the DMC. Everything else is C or C++ or Python. Anybody who's interested in helping out and converting said code into Java, come and talk to me. You will be one of my favorite people for a long, long time. Having said that, in the connectivity server, which basically it's there to handle a bunch of requests coming in from the switches, it has a whole set of routines. Basically, the most interesting one of this is the UDP protocol that I mentioned is sitting in its own subdirectory so that we can swap it out when we feel a need to, or when something better comes along. A little bit further, the gateway, this is just the user agent. I didn't get a chance to look through the kernel module other than to say it's a kernel module. Wonderful. It's very similarly structured. The OVS agent, just to finish it out, basically has 3 piece parts, one for talking to the controller, one for talking to the cluster server, and one for talking to the switch. So it basically acts as a little bit of plumbing, if you will. Yes, sir. Question?
If management controller does not go through SAL, then how does OpenDaylight and DOVE, in your case, manage different switches, like OpenDaylight switches?
So the question is, if OpenDOVE does not use the SAL, how do we manage regular OpenFlow switches? Okay. The answer is we don't.
Okay, just your own switches?
Yes. Yes. Today, OpenDOVE is just talking to its own switches. And that's one of the things that, again, you've hit on one of the open issues, which is how do we integrate this with the SAL, because we really ought to. We haven't yet, but we really ought to. All right. Question in the back. The question is, when I say manage our own switches, do I mean physically or virtually? Is that? Physical switches and so the question is physical switches and virtual switches. Today in OpenDOVE, we only have virtual switches. If somebody builds a physical switch that includes the implementation of the OVS agent, we could certainly talk to it and manage it as well. But today, in OpenDOVE, which is different from any product that might have Dove attached to it, we're talking about virtual switches only. You're talking about product now. I'm talking about open source implementations. So, if you want to talk about product, there's some nice gentlemen out here. I'm happy to talk to you afterwards. But this conversation is about our open source implementation. Any other questions? Okay, so we're going to go through a live demo or walk the tightrope without a net. And basically, the minimal setup that you need to make OpenDOVE run is 2 Linux hosts. We have 2 of them up in our North San Jose lab, and I've got tunnels into them, so we'll be live on those. On the first one, we've got the management controller, the client server, or I should say the connectivity server, and a VM with the gateway running, although we're not going to show the gateway. I just left it up there to keep things clean. We've got 3 guest VMs sitting in the other server, along with an OVS 2.0 switch and our OVS agent. What we're going to basically do with this is a simple 3-tier network. And by that, I'm going to put VM number 1 in the first tier. I'm going to put VM number 2 in the second tier. I'm going to put VM 3 in the third tier. 1 can talk to 2, 2 can talk to 3, 1 can't talk to 3. All right, so from question. No, that wasn't. And so the question was, what parts of OpenDaylight are being used? And no, that wasn't explained earlier. The honest truth is we are a separate parallel stack. We integrate, we make use of the Neutron bundle at the controller today, and we go off our merry way and do our own thing. Open topic is to make that integration better, because there are lots of things in the controller that we can make use of. There's lots of ideas that we have that we can contribute back to the controller. Just a matter of making it happen. So, good question. Good question. All right, another question. Yes? What kind of operations are done on the management plane? That's the question? OK. So the type of operations that we do are basic configuration. So setting up domain, basically what we call 0-day configurations, which we'll walk you through, the things that we need to do before we can configure the overlay. The overlay configuration operations, setting up domains, setting up networks, blah, blah, blah. And then ongoing management operations, checking the health of things, looking at statistics, ... One of the differences between OpenDOVE and the OpenDaylight model, and I was going to get into this in a little bit, but I'll talk about it now. If you look through the rest of the OpenDaylight code and how it works, they commingle the management and the control plane. So when I make an overlay, when I create a new network in the overlay, I'm pushing flows down to the switch. We tried that. We find it doesn't scale. If you think about it, it embeds a transaction model into your configuration. Because if you have n switches and you get to j and it breaks, you have to roll back 1 through j minus 1. So instead, we use what I like to call a pull or an asynchronous model. And Colin, in his talk about consistency, sort of alluded to this. We have a time stream, or I like to call it a change stream. And so what we're doing at the controller is we're setting up what we want the network to look like. It may not be what it looks like now, but it's where we want to get. And then everything, the gateways and the connectivity servers that pull that configuration from the controller, change by change by change by change, and report back periodically, hey, I've seen change number X. And so we know what the state is in the network based on what they've reported back. This allows us to do things in a much more scalable fashion because we just put stuff in the controller. If we're talking to an agent that's making a REST request, we put stuff in a controller, we're done. It'll get to the network eventually. It makes deletes a little bit more tricky, but with some appropriate logic and thinking, you can handle those, and that logic is embedded in the ODMC controller that you get. Does that answer your question? Great. Anything else? Yes, sir.
So in this one, what happens by the time the network has not reached a state where you really want it to be, how are the packets routed?
So the question is, how does this work when the network isn't in the state that it really wants to be? Before the network is before all the devices know about the network completely, you will have packets not make it in. However, the particular devices are set to pull change streams fairly quickly. We've scaled this mechanism out to, I think, about a couple of thousand of devices and not had any problems yet. And that was a single-threaded, not very well-coded server. It was just basically, let's slap the code together and does it work? All right, a couple thousand, that's good enough for now. We can make it better. But yes, you will have points where packets may not flow or may flow for a little bit before something happens. And if you have an end requirement that means you can't do that, then you have to think about how fast you want the cycles to be that you keep things updated. Right now, they're a couple of seconds. We didn't push it any harder than that because we didn't feel it was necessary, but this was, again, open source. We weren't aiming at any particular end unit requirement. Full disclosure, in the interest of full disclosure, IBM has filed a patent on this pull technology. However, part of the OpenDaylight license, if you look at it, is that patent technology is available without licensing to the OpenDaylight community. So if you pull it and use it as part of the OpenDaylight community, you don't have to worry about any licensing issues. All right. So change of gears. I'm going to actually configure this via the Neutron service, but as I said this morning, I'm not actually going to start OpenStack. You don't have to do that. You can just use your favorite piece of code. In this case, it's going to be wiztools.org's REST client, and I'm going to throw REST requests at the controller to do things. So from a northbound Neutron-like view, what I'm really doing is in the 3 networks and the 3 subnets that you see, I'm setting those up, and I'm going to attach the guest VMs one to each. And then in the Neutron model, to have connectivity between the 2 networks, I need to plop down a virtual router and stick a couple of interfaces in. And so we're going to create the interfaces, and we're going to plop those routers down and see what happens. So bear with me a moment while I move some windows over and explain what you're seeing. So first of all, the question is, the router shown on the slide an OpenDOVE element? No, that's a Neutron vRouter. So this is a combo window, a couple of tabs. This is the OpenDaylight controller window that we're going to use. You can see that it's running. We've got a tab here, which we will spend a lot of time with. There we go. This is where we're going to be running an instance of the ODCS. We'll get it started in a second, because I'm literally going to start this from ground zero and walk you through the 0-day configuration. So there's nothing there right now. This is some of the 0-day stuff, or in the middle, we're going to have a step where we have to connect up the VMs to the OVS switch. This is the window where we're going to do that. And then this is where we're going to start the OVS agent, and that happens to be the command line to do it, where that's the IP of the controller that we're going to be using. OK, so that's what's in that window. We also have, as I promised, we have, oops, there we go. As I promised, we have your favorite REST client. As I said, I use WizTools, and I'm not going to type these things. I have the requests preloaded. But as I said, the wiki page has the templates for all of these things. You just have to fill the values in with what you want to use for your particular network. And then last but not least, we have client virtual windows. I'm actually going to pull those over as I need them. I've got 3 virtual terminals into the consoles of the client, and this is getting cluttered enough. We'll pull them in when we need them, but for now, we'll start without them. OK, so right now, and I will actually reissue this, one of the things that we need to do in the 0-day is we need to configure what we call service appliances. That's our connectivity server and our gateway. So right now, I have nothing. Nothing's attached to it. OK, that's good. That's what we want. So we'll go over to this guy. And I'm not in the right directory. I am actually going to the places where the RPM will install, so that you can, oh, well, yeah. Let's try typing change directory. There's a good thing. OK. All right, so we've started up the client server. It's a combination of C and Python. It requires us to run a CLI right now. It's a user agent. Again, open topic. Take this away so that we can run it as a daemon, have another channel in to configure it with the seed information we need so you don't have to be sitting there typing things, because that's really boring. I'm going to log in with the developer password, which is on the wiki page. It is hook and ladder, if I can type it right. There we go. And we're going to add the controller address. And since they're on the same box, I'm going to just point it at localhost. Everything in OpenDaylight runs 8080. So, OK, so if everything has worked the way it should, that thing has actually said, OK, there's a controller there. Let me register with it. So it's made a REST request to the controller and said, I'm here. I'm available. Talk to me. So if I do this again, there you go. This is the information about that particular connectivity server. So I know the UUID. I know the IP it's sitting on. I know information about how to get to it. The most important thing is now the pull stuff is important because this is where it tells me what's the latest change stream I've seen. 0, because it hasn't seen anything yet. And then when the device sends that REST request to register, it isn't actually doing anything yet. It's just saying, I'm here. You can make use of me if you want. So the next thing you have to do is actually activate it, or we call it set its role. And that's, basically I'm saying, hey, I can function as a DCS. I can't function as a gateway, but I'm not doing either. So the next thing we do is wonder what, oh, OK, well, fine, be that way. My apologies. For some reason, I will move this over so hopefully so I can see it while I'm doing this, because going back and forth, we will set its role. And all we're doing in this request is saying, hey, be true. The important part is the UUID up at the top. That matches what we had. If you use REST requests to do things, you will want to use basic authentication, admin on all your requests. So in the interest of full disclosure, basic authentication, admin. So, all right. Send this guy in. OK. So now if we go look, we've changed it. So it's now ready and raring to go. So before next 0-day thing we're going to do is we're going to turn on the switch and attach it. So now that's actually a typo. It's not really using that. It's the DCS address. It's using that as the DMC address. But it's registering. So you can see it's got 201 status back on its REST request. So it's now registered and ready to go. It's got a name and a UUID. And if I come over here and I ask the controller, why are you doing that to me? Yeah. Apologies, this thing is definitely wanting to get my goat on this. But if I ask for switches up here, and I say, let's go do this thing. I've got a switch, and it's tunnel IP here, management IP here, name, and we said, hey, this is the first change in the stream. OK, so at this point, for this purpose, we've done everything we need to do in the 0-day. If we were doing stuff with the gateway, we'd have a few more steps. But now we're going to move on and create networks and talk about what happens there. So, and come back over here. OK, so apologies to those of you that know Neutron well. This is pretty much a really quick and dirty implementation of creating networks. I mean, those are not legitimate IDs or tenant IDs. Don't give me grief. I know that. We trust the Neutron. We trust the Neutron plugin that Kyle wrote to handle all of that properly. It lets us do some nice shortcuts to just test to make sure things work at this level. So we've created these things. Now, we have a slightly different view of them inside of OpenDOVE than we do at the Neutron level. So let's take a quick look at that and see what's going on there, because this will be important. Okay. And all of the APIs that I'm using that are controller NB or SBv2 OpenDOVE, those are also documented in the wiki. Links to the documentation are on the wiki page. They're actually generated via Enunciate when you build. So if you start building the codes, you'll build your own copy of the APIs. It is version 2 because the decision, so the question was, why is it version 2 up there if this is version 1 of OpenDOVE? The decision was that the Hydrogen release of the controller would use v2 as its URI. There was a v1 early pre-Hydrogen, and it pretty much got dumped. So consider it under the heading of API governance. OK, so here's the name of the network I created in Neutron. And the important thing to OpenDOVE is the virtual network identifier. This is the tunnel ID or the identifier we stick on the VXLAN packet. So it shows up on the wire. So we got to know it. That's the network ID field. Now, when you work with Neutron and OpenDOVE, Neutron, if you're familiar with that API, tenants are something that scopes everything, but you don't really have the ability to create them in Neutron. They sort of come to you from Keystone or inside the packet that you get. So there is some implicit creation of what we call domains here based on the tenant information in the request. So that is why you see a domain UUID here. That's the domain that we created to represent the tenant that was implied in the Neutron request. So there's a little bit of shuffling the cards here, a little bit of 3-card Monte going on. OK, so let's go over. And oh, yeah, by the way, one of the things that all of the southbound devices do is heartbeats, because we want to know they're still there. We want to know what's going on. As we're talking, you can see DMC heartbeat response status 204. That's basically us coming back and saying there's no content. We've got nothing for you to do. We know you're there. Life's good. All right, so let's go back over here. And, well, actually, let's come back over there. So what we're going to do is we're going to take a look at, nope, not 12. I want 2, and hopefully I am right. Yes. OK, so I've asked the DCS, what do you know about domain 2? Now, how did I know it was domain 2? Well, I cheated, but I'll explain how you can know it was domain 2. While the DMC knows domains by UUID, the DCS knows domains by number. And the number we use is the number of the change request that the domain create was. Since I knew that I had registered a switch as change 1, and the first thing I do when I create networks is to create a domain, I know that that's change 2. So that's how I knew. There are URIs documented that let you look into the change stream. When we get this done, if people want to come up and see that, I can go into the details of that as well. I wasn't going to do it here. But basically, what's happened is this DCS has not only pulled the fact that domain 2 exists, it's pulled the fact that there are 4 virtual networks. And it gives you their numbers. Wait a minute, you say. You created 3 virtual networks. You're right, I did. One of the things that OpenDOVE does to support sending multicast traffic off the cloud is we create a special virtual network identifier that we call the external multicast. And you, the northbound guy, don't ever see it. You don't manage it. It goes hand in hand with the domain. But it's there if you want to send multicast traffic off the cloud to the external world. OK, so we don't have any endpoints. We'll get those later. We don't have any implicit gateways. We don't have any subnets. We just got a couple of networks. We can't really do anything with them yet. So the next thing we want to do is now we want to say, let's create, ooh, that's not what I wanted. Apologies while I find where my mouse went. That's better. Note to anybody who does this, using two different resolutions can get very interesting at times. OK, so now we're going to create subnets, and I'll bring my mouse back over and pan up a little bit. So basically, I'm saying network number 1, I'm going to make it 10.1.0/24 and 10.2.0. And that's how I'm going to fill in those network pieces that I showed you on that Neutron view of the world. OK, so let's go ahead and do that. OK, they're done. And now, if I come over here, and I'm fast enough, and I may not be. No, I wasn't. If I was fast enough, I could have caught it showing me just one of those, or just 2 of those, or just 3 of those. But that's to your question about what happens in terms of the configuration not being there. It's pretty darn quick. I mean, I've caught it, but it takes some serious pounding on the thing to get there, or doing something nasty like pulling the plug in the middle of it to force it to a situation where it can't update. So the question is there a way to determine that the configuration was not sent? Yes. And that is, every time that the connectivity server sends a heartbeat back to the controller, it says in that heartbeat, this is the last change version I've seen. So if I go back and I do, oh, you're not even going to let me do that? Well, that's really rude. Where's my? There's my mouse. So if I go back and I look at the service appliances again, if I come back and look, it's now told me it's seen through change version 12. So if that doesn't change, I know there's a problem with connectivity because I'm not getting reports. Either the connectivity server isn't getting the updates, or I'm not getting the heartbeat back, which means communication ain't working. OK, so now we've got the subnets in place. So the next thing we do is let's attach VMs to the switches. And pardon me while I do a little typing. This is another one of those places where this is manual, and there's an open topic to make it not manual. But I thought I heard a yes, question.
Yeah, so where are all these stored? These are still virtual, right? It's all in the air around.
So where is this stored is the question. On the controller, they're stored in InfiniSpan, not persisted. So if you turn the box, if you turn the controller off, it's all gone. This is a general problem with OpenDaylight. You know, if you look at the OpenDaylight persistence model, that's one of those helium things. On the control in the connectivity server and the gateway, it was a conscious decision to make them stateless, in the sense that they do not persist configuration to disk. It's all in memory. We want it to be the case when the box comes back up, it's ground zero. Because the worst thing that can happen is I think I have a configuration for net 10, for virtual network 100, and I've gone down, and in the meantime, virtual network 100's been deleted and added to a different tenant, and now I come back and I start sending traffic across tenants, and I'm in deep trouble.
Okay, you can argue other way also, right? Like you would have created 5 networks in Neutron, and then your OpenDaylight goes down and comes back up. In Neutron, you have these 5 networks there, but in Daylight, you don't have that.
Okay, so the question is, you can make the same argument. You have the networks, and you've created 5 networks in Neutron. OpenDaylight goes down. You come back up. They're not in OpenDaylight. Neutron says they're there. What do you do? And my answer is, that's why I say persistence is a helium thing for OpenDaylight. This is a general question. In my opinion, this is a general shortcoming that has to be addressed in helium. OpenDaylight really needs a persistence model. And it really needs to let people say that piece of data needs to hang around between reboots, because if it doesn't, life's going to be really, really bad. Very good question. Very good question. All right, so what I'm going to do here, again, if I find my mouse, I'm not sure where it went this time. Okay. So we're going to, one of the things that I'm actually going to do is I'm going to look back into the controller. I showed you these before, but I'm going to want them actually now. I actually want to know the mapping between here and here, because I'm now going to go and I'm going to attach them to the switch. And this is going to be fun because I'm going to try and do it without quite being able to see the screen. So this could get really interesting. Now, as is the case with most things Unix and C, VNet 0 is the first virtual client, so I'm going to attach it to network 1, 143.416.96. Okay, that's the first one. Okay, this is, that's the external multicast. We don't care about that. That's the third one, so that would be VNet 2, 101.829.11. Yep, okay. Oops, yeah, I forgot the shell. That's better. All right, and then last but not least, we've got to do the other one. Now, these don't actually show up anywhere other than in the switch. It's the switch setup in itself. But if we've done it right, then the next step will work. If we didn't do it right, then the next step won't work, and we'll have to go back and fix it. Okay, so what's the next step? The next step is to pull one by one. I'm going to pull these client windows over, and I'm going to ping. I'm going to pull the client windows over, and I'm going to ping the default gateway address. I'm not going to get an answer back because it's an implicit router. We don't actually return pings. I've talked to the switch guys. I don't quite get why. And I think that would be a nice thing to actually return an answer. But I'm told that it's not that easy. So again, open topic for anybody who wants to contribute. If they could figure out a way to make this work, again, I would be very happy. But the important part of this is that when I do this, I actually, the switch picks up the fact that the client is there, it's trying to do something, and it registers endpoint information with the DCS. This is important. So We'll stop that. We don't really need it to do much more than it's already done. That's number 3, so okay, yeah, a couple of those, that should be good enough. And bail out of vert and ping. Yeah? Oh, yes, yes, yes. Okay, thank you. Yeah, that won't work. That won't work. So we'll find our mouse again, which has very cleverly disappeared on me. Where did it go now? Ah, there it is. As I said, the interesting thing is that this particular window, that particular window is not actually parallel to this. It's sort of off and down to the side. So there's some space where I can have the mouse and not actually know where it is. Again, hence my comment about if you do this and they don't line up, be prepared for some interesting situations. All right, so let's go back and fix that other one. Thank you for pointing that out. And while it does its thing, I will make sure my vocal cords don't go away. Okay, so if I come back over here and I look at this window, unfortunately I didn't have it up, but it's been doing some things. Switches it. Ah, there we go. Much better. Thank you. So this has been registering endpoints. So when I go to the DCS window, if I did everything right, I now have 3 endpoints registered, 1 in each network. So this is good. If I hadn't got it right, what I would have to do is go back to where I was adding the ports, delete one, and add it back with the proper VNID. Because what the connectivity server is, it's looking at the MAC and IP address information coming in from the switch. The switch says, hey, this is supposed to be part of VNID 1. The connectivity server is checking and saying, yeah, that's part of VNID 1. OK, we'll let it in. If I try to say 10.1 is part of VNID 2, it says, that's not part of VNID 2. Go away. OK, so now we're ready to do the fun part. And so what we'll do is, can folks in the back still read that? All right, well, hopefully you can see enough that something's happening. And we're going to do the infamous ping test. So we're starting to ping. So if I go over to the switch, it's trying to ping. It says, hey, I've tried to set stuff from 1.0.3 to 2.0.3. Can't do it. Communication prohibited by policy. There's no policy between the 2 VNIDs. Traffic is denied. So let's change that. And the way we do that, and we'll pull this over here in front, is we first create a Neutron router. So now and needless to say, we really don't check the UUIDs. Because, yeah, I for grins and giggles called this internal router ID, which ain't a UUID I know of, but hey, it works. All right, so we've got the router, but communication still isn't working. Why not? We haven't attached the interfaces in Neutron to it, so we don't know in the controller to say, hey, we got to put policies between these. So first we add one, Oops. Why did you not like that? Or more likely, no, I wonder if I suspect I have a mouse bounce. So I am going to make the wonderful assumption that it worked, and I just got a mouse bounce. Ooh, no, it really didn't work.
The ID here is number, and then you had after this.
Oh, all right. Well, that would be consistent with stuff going on. So let's back up, and we'll, in the typical fashion of live demos. Where'd my mouse go this time? Okay, so it's internal router ID. Name internal. No. I forgot a step. Before I can attach an interface to the router, one of the things that I define up there is a Neutron port. And I haven't created any Neutron ports. So, apologies for skipping a step and messing things up. Okay. All right, so we've got a couple of ports created. Now we can. Now this should work. Otherwise, I will be really embarrassed. That's better. And we add the second one. We add the second one. And if you noticed over here, we now say forward to local switch. And if you look here, we have pings flowing back and forth. And if I go back to the connectivity server and ask it, it sees a pair of policies. Now, in OpenDOVE, policies are one way, so we have one from source to destination, one from destination to source, and that's how they end up working. So that's the first part. Now, we do have the room for another hour. Do people want me to add the second part, or do we want to just go on and talk and say, we see this, we get it, let's go on and talk about some other things? Well, I'm going to go on and finish it up. So we're going to come back to this guy. And so I had mentioned the wiki root a couple of times. That's the URL. If you go there, again, there are steps for all of this so that you can recreate it yourselves. If you get involved in developing with OpenDOVE, we welcome you with open arms. We have our own Jenkins because we're on our own OpenDaylight project. We have our own Jarrett. I apologize. The Git isn't up there. It's OpenDOVE.git. You know, if you're familiar with the controller being controller.git, same path, OpenDOVE.git will get you the OpenDOVE stuff. real quick, again, this is on the wiki pages, but how you build all of this. ODMC builds with Maven, your typical Java Maven project. ODSC is make, GCC. You may need to get Jansen and libevent because we use those, so you may need the dev packages. And then the gateway user agent is a C++ beast. The kernel module, when we release it, is just your basic make because it's basic C code. And then the OVS agent depends on having Open vSwitch 2.0.0. Earlier versions won't work. I am told they don't have what we need. It also builds with make. So, and I think, sans other questions, that's it. Thank you for your patience and your time. I appreciate folks coming.
Thank you.